Hello everybody, and thanks for the opportunity to speak to you today about Lyngbya. So I'm a harmful algal bloom person, work on water quality, and Lyngbya is a classic example of a harmful algal bloom species. So let's talk about what is Lyngbya. It's actually a blue-green algae or a cyanobacteria, and like all plants, they need nutrients, light to grow, and of course CO2. We've got plenty of that. So Lyngbya, it's also known as fireweed, and it grows on surfaces and particularly likes relatively shallow waters where there's enough light. It can grow on muds and sand, and it can form these really thick mats, as you can see in this photo. One of the reasons why we care so much about it is because it produces toxins, varying levels of toxins and all range of manner of toxins that can affect humans. So it can make the skin really itchy, for example, if you pick it up. It also can lift off the bottom and form these rafts that move around in waterways and then settle in other places or get washed up on the beach, which is where it can cost a lot of money for councils to have to try and get rid of all that material. One of the reasons that it's also detrimental for the environment is because it smothers seagrass beds. Of course, there's a lot of fish and other species that use seagrass beds as juvenile habitats, and it smothers the seagrass, creates low oxygen conditions when it gets in bloom proportions. That's not to say that it's not a naturally occurring part of the ecosystem. It's really just when it starts to bloom. Much of the research, well, it started back in the 1990s, the research, and much of it has occurred 10 or 20 years ago. And despite the fact that it's still blooming periodically through much of southeast Queensland, and I'll share some more information about that in a minute, really in recent years there hasn't been a lot of research done on it and not a lot of work published. So the problem continues. I like to think of Lyngbya as a sentinel species for the health of Moreton Bay and more broadly in southeast Queensland, because it integrates a whole lot of things that come in from catchments and affect the marine waters of the bay. And so whilst we can measure water quality and we can look at changes over time, the frequency, the scale, the magnitude, the duration of blooms really are kind of a sentinel for a bay that might be changing. It links with things like, as Alistair was talking about the silting up of Moreton Bay as it gets shallower. Well, that's potentially more habitat. So I think it's an important species for us to continue to keep our eyes on. So here's a nice conceptual diagram, classic diagram synthesising the work done by Judy O'Neill and Bill Dennison back in the 1990s. So they first started the work on Lyngbya in southeast Queensland, worked with the local fisherman in Bribie Island, Greg Savage, and he brought it to their attention and they started working on what's causing these blooms. And really, when you sort of summarise that work, the work that they did and a range of other people did, you can sort of see it in this conceptual diagram. So you don't get blooms of algae typically unless they've got enough nutrients to grow, like any plant. It can pop up periodically, but it's not going to form these large blooms unless there's enough nutrients. And this is a conceptual diagram showing the pumice stone passage influences. And that was not just nutrients like nitrogen and phosphorus that we typically think of, but it's also things like organic carbon and iron also seem to play a role in stimulating the growth of this species. So we know that nutrients are important, but if it was just that simple, we'd have blooms when it rains, right? That's when the inputs from the catchment are at their greatest, but it's a bit more complicated than that. So what I've tried to show here is that by reading the literature and summarising the literature from southeast Queensland is to try and give you a sense of what the drivers of blooms are and why we get them sometimes and not others. So if we can start by thinking about climate and human or anthropogenic drivers. So I've got two categories, the indirect and direct. What I mean by that is indirect means that you need those background conditions to get the blooms. doesn't mean that you're automatically, when those background conditions, going to get the bloom straight away. So that may happen in it with a delayed effect. Then there's the direct drivers. And there's been work that's shown quite clearly that when it's warmer, like in the summertime, when it's calmer, that we're much more likely to have blooms. Doesn't mean we don't sometimes have blooms in the wintertime, but we're more likely to get them in the summertime and when it's calm. The indirect drivers are about nutrients. That can come from runoff from the land, how big those inputs are, but also wind-driven events that can mix up those shallow environments and bring nutrients into the water. So all those things can directly and indirectly affect blooms. Then there are the consequences. So the consequences are high nutrient loads. And when we've already got a Lyngbya bloom that's happened previously and all that rotted material has broken down, then it becomes its own nutrient store if it gets mixed with the tides and the winds and the nutrients go back into the water. So we can have these delayed effects. As I mentioned with the direct drivers, we have these optimal temperatures for growth and we know what they are. We know when there's more light and when it's calm and material doesn't get ripped off the bottom of our waterways, then we're much more likely to have the blooms. So the impact, as I mentioned, there's a few different dimensions. There's how often the blooms occur, there's the scale of those blooms, and there's how long they last. And all that varies from year to year. And as I mentioned, we have that legacy. If we've had a bloom, we have those stores of nutrients and carbon from the previous blooms. It sort of becomes self-perpetuating. That's the trouble with algal blooms. Once you start to get them, they're kind of really good at self-perpetuating. And then the biomass can lift off and move to other areas, and then it can impact on the shoreline and on recreation. So that's our current state of knowledge of Lyngbya. Well, okay, so we know that maintaining, looking after our catchments, reducing the loads of material that come in are really important long term to stop the bay getting, inverted commas, worse and the whole of southeast Queensland water quality deteriorating. But people are also interested in what we can do in terms of management actions. So one of the things we've been looking at, and this is help with an honours student, Renee Whitchurch, was to try and look at what control mechanisms could be. One of the things we looked at was hydrogen peroxide. Now, the nice thing about hydrogen peroxide is when you put it into water, it very quickly breaks down to water and oxygen. So it isn't detrimental to the environment like some other chemicals you might put in. It's been used throughout the world to control algal blooms, and particularly cyanobacterial blue-green algal blooms because they are particularly susceptible to hydrogen peroxide. And so we looked at a whole range of concentrations that you can see in this graph to see at what concentration you could lower the amount of these blooms. It was all done in the laboratory. But it's clear that we can use this chemical to control the blooms. These haven't been done at a larger scale out in the field, and we still have the challenges of getting permission to use this chemical in the environment. But there are some clues there that there are some management strategies, particularly if they were implemented early as the blooms are just getting going, before they form these massive big accumulations. There's also research going on about the toxins, and that's work that Queensland Health is doing, and they've been, whenever they can, getting hold of samples from southeast Queensland and analysing the Lyngbya to see what toxins are in there. So what they're finding is that toxins are present in a lot of the samples. And so that's a concern from the human health point of view, as I mentioned. The trouble is that we're really just scratching the surface in terms of our understanding of the toxins, and work on that is continuing. I now want to move to the monitoring part of that, and I think that's where we have one of our biggest challenges with Lyngbya. We don't have a southeast Queensland-wide monitoring program, but we know that periodically Lyngbya blooms in different places. It popped up at Wynnum this summer. In the last couple of years, it's suddenly popped up down on the Broadwater, down the city of the Gold Coast. They'd never had it before, or not that they knew of. There's some areas where it's quite regularly blooms. So the challenge is, how do you monitor it effectively? Now, Greg Savage, as I mentioned, the local fisherman from Bribie, he's been a total legend, and he's been out there monitoring using his rake method. And you can see his rake there on the right. He's been monitoring back since, this data is back to 2006. And you can see some years it blooms, some years it doesn't. It's not the year of the rainfall inputs. It might be subsequent years, and that's all about those complexity of factors that affect the blooms. So despite his best efforts, he's really only doing Deception Bay, the Goodwin Beach site. There's all the rest of the bay we know nothing about. And it's expensive to monitor. That's the problem, and that's why it's not being done. So one of the things that it was going so well. There we go. One of the things that that has been we've had a bit of a look at is using drones. And the nice thing is, because it forms these black clumps that you can hopefully see quite clearly, there is the opportunity to use that sort of imagery and then use some clever computer analysis to try and get a better handle on it. Because the reality is we don't know if the bay is getting worse, because we're not doing the monitoring. We've got the monitoring at Deception Bay, but we don't have it more broadly. So I hope that gives you a better feel for a state of knowledge of Lyngbya, but please keep an eye out for it. It might start appearing in places it hasn't before. Thank you.
Thank you. We have a question from the floor. Could seaweed farms help control food for Lyngbya, taking the nutrients out of the water?
Yeah, you'd need a lot of seaweed farms. I'm all for seaweed farms. I mean, I love algae, don't get me wrong, but you would need a lot of that. And then, the problem with anything, you put it out into the waterways and people start complaining because they can't zoom their boats around, or it's visual pollution. So it can be a little bit challenging to try and use a sort of a more of a natural solution, which I think in theory is a great idea. It can also be a bit challenging to try and use that to mop up enough of those nutrients to really have an impact on Lyngbya.